It was supposed to be impossible. For as long as we've known about planets, we assumed they orbited stars. It's the most fundamental rule of cosmic architecture. Gravity pulls matter together, and what orbits stays orbiting. Stars are the anchors, planets are the travelers. But in the year 2000, a telescope in Hawaii pointed at the Orion Nebula and found something that shouldn't exist. A planet, floating alone, no star within billions of kilometers, no solar system to call home. The astronomers called them rogue planets, free-floating planets. Or, if you want to sound more dramatic, planets that orbit nothing. The case was open. Here's the problem with finding rogue planets. They don't emit their own light. They don't reflect much either. Most of them are cold, dark, frozen chunks of rock and gas drifting through interstellar space. So how do we find them? Method 1. Gravitational microlensing. When a rogue planet passes in front of a distant star, its gravity bends and amplifies the starlight. The star brightens for a few hours, then fades. It's like a fingerprint left on the light, brief but detectable. In 2011, astronomers studied 50 million stars and found 10 such signatures. Jupiter-sized worlds passing alone through the dark. Method 2. Direct imaging. Young rogue planets, only a few million years old, are still warm from their formation. They glow faintly in infrared. The Spitzer Space Telescope and ground-based observatories have snapped pictures of these lost worlds, floating freely in young star clusters. But here's the catch. These methods only find the ones that are relatively close, or relatively young, or massive. The vast majority of rogue planets remain invisible. We found over 100 of them. Estimates suggest there are billions, maybe trillions. The galaxy is full of planets we can't see. Let's start with the most intuitive explanation. Most planets form in disks of gas and dust around young stars. These disks are chaotic places. Newborn planets compete for space, migrate inward, fling each other out of orbit. Computer simulations show that in the first few million years of a solar system's life, gravitational interactions can eject planets entirely. One too close encounter, one gravitational slingshot, and a planet exceeds escape velocity. It leaves its star forever. This is the exile theory. Rogue planets were born like any other planet in a system around a star, and then thrown out into the interstellar void. If this is true, rogue planets should look like normal planets. Rocky cores, possibly gaseous envelopes, maybe even moons. They might carry the chemical fingerprints of where they formed. And there's evidence. Some rogue planets appear in young star clusters, moving at speeds consistent with ejection. They're kinematically tied to their birth environment, like runaway children who haven't wandered too far. The exile theory has a problem, though. It struggles to explain how so many of them there are. Here's another possibility. Not all collapsing clouds of gas and dust become stars. Some fragment into very small pieces, too small to ignite nuclear fusion, but large enough to form planet-sized objects. These are sometimes called sub-brown dwarfs. They form like stars, alone in the dark, never gaining enough mass to shine. They're the universe's failed attempts at creating suns. If this is true, rogue planets should have formed directly from gravitational collapse without ever being part of a planetary system. They would be more like tiny cold stars than ejected worlds. Evidence? Some rogue planets appear isolated from any star-forming region. Too old, too far, moving in random directions. They show no connection to any birthplace. They seem to have formed alone, drifting into the galaxy as independent objects. And the discovery of objects with masses as low as 0.6 Jupiter masses in the trapezium cluster suggests that even planetary mass objects can form through direct collapse. The boundary between planet and star might be blurrier than we thought. So we have two theories. Exiled planets, failed stars. The evidence points to both. Maybe the truth is both are correct. Some rogue planets were kicked out. Others were never caught in the first place. Now here's where the story gets strange. Even without a star, some rogue planets might not be frozen solid. In 1998, physicist David Stevenson proposed that a rogue planet with a thick hydrogen atmosphere could retain enough heat to maintain liquid water. How? Geothermal energy, radioactive decay in the core, tidal heating if it has a large moon. The same forces that keep Earth's interior hot could work on a planet in permanent darkness. A thick atmosphere acts like a blanket, trapping infrared radiation and preventing the planet from radiating away its heat. The surface might be frozen, but beneath the ice, an ocean could exist. Liquid water, perhaps even hydrothermal vents at the ocean floor, the kind of environment where life on Earth may have first begun. We haven't found evidence of such oceans yet, but it's plausible. Rogue planets might be the most common habitats for life in the galaxy. Worlds drifting in darkness, with oceans kept warm by their own internal fire. It's a haunting thought. Life thriving in the eternal night. No sun to warm them, no sky to see, just heat from below, water all around, and whatever strange ecosystems have evolved in the deep. We started this investigation with a simple question. Can a planet exist without a star? The answer is yes. We found over 100 of them, maybe more. But the case isn't closed, it's barely beginning. We don't know how many rogue planets there are. Estimates range from billions to trillions in the Milky Way alone. We don't fully understand how they form. We haven't confirmed whether any of them have oceans. And we certainly haven't found life. The galaxy, it turns out, is full of ghosts. Worlds that wander alone through the dark. Born in light, cast out into shadow. Or born in shadow, never knowing a star's warmth. They drift between the stars, invisible for most of their existence. Occasional gravitational lenses give them away. A brief infrared glow marks their youth. Then they fade into the cold, the dark, the silence. We call them rogue planets. But maybe a better name is the unknown, because that's what they represent. Not just wandering worlds, not just ejected exiles or failed stars, but a mystery we haven't solved yet. Somewhere out there in the space between stars, planets are moving, drifting, existing, and we have no idea what stories they could tell. The universe is stranger than we imagine, and the strangest parts are the ones we haven't found yet. Thanks for watching. If this mystery intrigued you, hit subscribe. New episodes exploring the unknown drop every week. Keep looking up, keep drifting,